Hello, everyone. So this is number 24 on AMC 8, 2023. So this is one of the challenging questions on the test, to be honest, but at the same time, it's not really that bad, okay? So we have ABC, okay, the isosceles triangle ABC, we have two of those, and they have side AB and BC, okay? And in the figure below, the segments are drawn parallel to AC. So this segment is parallel to AC, this segment is parallel to AC, so that the shaded regions are actually having the same area. Okay. The height of the two unshaded portion, which is 11 and 5 is given. What is the height of the ABC? Okay, since we are going to look for the height of the ABC, so it's better for us to actually go ahead and draw that. Okay, so I'm going to drop this altitude and I'll drop this as well. Okay, so we do know this is 11, so that means this whole thing was h. So I'm gonna show that. So that means this is gonna be h minus 11 if I really want to write it. Since this whole thing was 11, so and then this is 5, so that means this piece, the top parts, like this guy, is actually h minus 5. Okay, and we are told the area of this region and area of this region is equal. So I'm not sure if you did the number like other question. I guess it was number 19 on the test. But yeah, there was a relation between the area of the similar triangles, which is I mentioned there as well. So we do have two figures are given the same area, which is we do need to use that information. And since we have ABC and ABC are the same triangle, so they are identical, not just similar. And we are told this guy and this guy is parallel, which is why the triangle right here and the triangle right here is actually similar because of the parallel line makes the angles are equal. So those corresponding angles. And like this guy and this guy, and then this guy and this guy are equal. The same goes right here. So which is why this triangle, the shaded one and ABC, and this white one and this ABC are similar. So why this is important? Because we do have area. We want to use that relation to the similarity, okay? So if you want to find the ratio, since they are similar, that means their all parts are actually proportional. So if I take this smaller triangle, the height is 11. Okay, the ratio of this height to the ratio of the height of ABC is h. So that's gonna be my ratio of the heights, and that's basically my proportion. So if I square this guy, okay, so which will give me 121 over h squared, and this ratio is actually area of this triangle. Maybe I should write it. Let's say this is DE, and I'm gonna call this is KL. So the area of the BDE over ABC or BAC, whatever. Okay, I'm gonna write in the same order. So BAC. Okay, I'm gonna leave it for now. And then if I use the same thing right here, the area of the BKL, so the area of the BKL divided by area of the BAC is actually equal to the height of this triangle is h minus 5. The height of the ABC is h. And I need to square this guy to find the ratios of their areas, which is I'm not going to multiply, like I'm not going to expand those, but I'm going to write it as h minus 5 squared over h squared. So what is that like look like? How do we use this information to get those, right? We are told this region, the area, is same as this region. So the whole region is a multiple of h squared. Let's say this is just the whole region is h squared as area. And we know BDC is 121. So if you want to find this shaded region, okay, so that it looks like h squared minus 121. Okay, so again, I just didn't really want to write times something because this is ratio, it's not actual values, but I can just say times x. And then since this is going to be eliminated in the other equation, so I don't really need that. And I will do the same thing with this part. So the area of the larger triangle was h squared, and then smaller one, h minus 5 to the second power. So this is already good. So h minus 5 to the second power. So this guy and this guy is given as the same area. So let me write this. H squared minus 121 equals H minus 5 squared. And you can just go ahead and expand this one. If you do remember the square of binomial, it's good to expand like that. If you don't, just write H minus 5 times H minus 5. So you can just do H minus 5 times H minus 5. H times H will be H squared, which will cancel with this. H times minus 5 is minus 5. Minus 5 times H is another minus 5, which is going to be minus 10H. And minus 5 is 25. Okay. And then the last side was H squared minus 121. So we are almost there. So this guy and this guy will cancel. So there is no quadratic. So we can add 10H to both sides. So 10H, add 121 to both sides. So 25 plus 21 is 46. So 146. And it's really nice to divide by 10. So that will be our answer, because the question was asking the H, which is the height of the ABC. And for number 24, actually this much work is not a big deal, okay? But again, in this question, I just like to remind two things as I did before probably. So in one of the questions in AMC 10 this year, they had actually a similar question like this one. The figure wasn't the same, but we use actually square root binomial in that case as well. So as you see, geometry problem, we are using algebra. So square binomial is useful, even though if you don't know that one, so you can just expand like this, which is okay, but it will take less time if you use it. That's one thing that I highly recommend you to work on it. And second thing, area ratio and similar triangles. Okay, that's also another big deal. Okay, so I'll see you in the next video.